This is SpaceTime, Series 26, Episode 115, for broadcast on the 25th of September 2023. Coming up on SpaceTime, astronomers discover a cosmic ribbon surrounding a galaxy, a new location in the search for life on the red planet Mars, and the International Space Station forced to take evasive action in order to avoid oncoming space junk. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have identified a spectacular stream of hydrogen wrapped around a distant galaxy like a sort of giant cosmic ribbon. The stream has completely encircled the spiral galaxy NGC 4632, located some 56 million light-years away in the constellation Virgo. The stunning object appears to be a rare polar ring galaxy, which includes a ring or disk of material perpendicular to the orientation of the galaxy itself, and which are among the most striking and mysterious objects in the universe. The cause of polar rings remains an open area of debate. They could be material sheared off a neighbouring galaxy, or hydrogen gas flowing along cosmic filaments, that is, strands of dark matter around galaxies and accreted by gravity. The findings, reported in the monthly notices of the Royal Astronomical Society, were obtained as part of the Wallaby Wide-Field ASCAP L-band Legacy All-Sky Blind Survey. Wallaby is studying the entire southern hemisphere skies in the 21-centimetre neutral hydrogen band using the CSIRO's Australian Square Kilometre Array Pathfinder ASCAP, a network of 36 12-metre parabolic dish radio telescopes spread across the Western Australian outback northeast of Perth. One of the study's authors, Professor Babel Kowalski from the CSIRO's Australia Telescope National Facility and the University of Western Sydney, says the galaxy's ring of gas can only be seen at radio wavelengths. She says the rings orbiting the galaxy at right angles to its spiral disk, like a parcel wrapped in a ribbon of cosmic gas, dust and stars. Kowalski says NGC 4632 is one of only 2 polar ring galaxies the teams have identified out of some 600 galaxies that have so far been mapped out of the first small survey from Wallaby. Eventually, the survey expects to reveal more than 200,000 hydrogen-rich galaxies, among them many more unusual galaxies just like these with polar rings. The findings suggest that between 1 and 3% of nearby galaxies may have gaseous polar rings, and that's much higher than suggested by optical telescopes. While this isn't the first time astronomers have observed a polar ring galaxy, NGC 4632 is the first using ASCAP, and so there may be many more to come. Kowalski says the Wallaby survey aims to observe the whole southern sky using ASCAP to detect and visualize the gas distribution in hundreds of thousands of galaxies.
Well, what we're studying are galaxies mostly. So we're using Pathfinder, so short ASCAP. It's like 6 kilometers in diameter. It consists of 36 telescopes all working together as a radio interferometer. And it has some really, really special receivers. These receivers can see a much larger portion of the sky than we previously could with the older version of the just single horn receivers. So what ASCAP is a fast survey machine. And so we're surveying the skies. And one of the projects that I started over 10 years ago is called Wallaby, where we're looking for hydrogen in galaxies. So we did some pilot surveys. These are now underway. But this particular discovery of a polar ring made out of hydrogen, so it's talked about as a ribbon of hydrogen, is surrounding a normal spiral galaxy. So if you only look at optical images, you see a beautiful galaxy with spiral arms. And when you look in the hydrogen, you see the disk. And on top of that, you see a ring going around the pole of this galaxy.
Now, this is just one galaxy, NGC 4632. What about other galaxies? Are we seeing the same thing in other similarly structured galaxies?
We see it very, very rarely. So among the 100 resolved galaxies in the pilot survey, 2 of them seem to have polar rings. In the literature, we know about 100 of these. Now, with Wallaby, we have estimated that we can detect 200,000 galaxies, at least. So, several hundred of those are likely to have polar rings.
All right, we know that polar rings are made out of hydrogen. What is causing it? Is this just interstellar gas that's somehow been moved out by magnetic forces? Is it pushed out by an active galactic nuclei? Or what's the theory?
So, very, very likely these are gravitational forces.
Right.
Galaxies usually don't live alone. They live in groups or even clusters, and galaxies interact with their neighbors through tidal forces or gravitational forces. So the outer hydrogen disks of galaxies are less strongly bound than the central parts and can be removed through these tidal interactions. So in this case, it's quite likely that this particular spiral galaxy, NGC 4632, has removed gas from another galaxy and captured it in this polar orbit. And Parkes got its new multi-beam receiver now over 20 years ago. We also surveyed the sky, but not at the exquisite resolution that we can now do with ASCAP. But that was fine for the Milky Way. So we see this giant band of hydrogen connecting the Magellanic Cloud and the Milky Way. So that's called the Magellanic Stream. The Magellanic Clouds are 2 galaxies, a large and the small Magellanic Clouds, smaller than the Milky Way. So it was relatively easy for our Milky Way to remove some gas from these galaxies, and it's stretching in this band. It hasn't formed a polar ring yet. It may, but it's not always going to happen. Depends a bit of the orbits of the galaxies.
On the trajectories, yeah.
Exactly. And sometimes you then see new stars forming out of the hydrogen gas, because the hydrogen is the fuel for star formation. That's what stars are made out of. So hydrogen collapses kind of to form dense molecular clumps, and then new stars can form.
Right, so this hydrogen we're looking at is not ionized.
No, this is neutral atomic hydrogen that we're looking at. We use the 21 centimeter line that our radio telescopes can easily spot.
There are different types of hydrogen that we see, aren't there?
Yeah, so we have the very, very cold molecular hydrogen.
That's the stuff that makes stars.
Yes, that's right. And it lives around, 10 Kelvin or around that kind of temperature. So it's super, super cold. And only when it gets heated up, when the molecule starts to vibrate, then you can see it in the infrared. You can't actually see it when it's so cold. The molecular hydrogen doesn't have a spectral line, but it hangs out with carbon monoxide. And carbon monoxide we can see at 3 millimeter wavelength. And then there's the atomic hydrogen gas that we can trace with radio telescopes like ASCAP or CSIRO's compact array in Narrabri or the Parkes telescope through the 21 centimeter line. And then there's ionized hydrogen gas that is much hotter. And so there we see where stars are actually already forming. We usually have clumps of ionized hydrogen gas.
And how do we see that in the visible?
In the visible, yeah, in the visible. When you look at the beautiful HST or now JWST images, it's usually shown as a red glow.
They're the red clouds we see. They're pretty red clouds.
Exactly. That's the ionized hydrogen gas.
When you do your research and you look for these things, is it telling you something about galactic evolution?
Absolutely. It's telling us about how galaxies evolve, how they form in the first place. But one really important study is also that of dark matter. We see the stars. We can measure the hydrogen gas and its different forms, as we discussed, molecular, atomic, ionized. We can also see dust, for example, in the Milky Way. We can trace the dust. But we know from the rotation of galaxies that they have 10 times more matter than we can detect. And so we have named this dark matter, and embarrassingly, we don't know what it is. We know how much there is. We know roughly where it is, but we really have no idea what it is. It could be one thing, it could be many things. So the polar ring, for example, that, this ribbon of hydrogen around the pole of this galaxy is likely stabilized by the dark matter halo of this galaxy, which means polar ring galaxies help us studying the dark matter distribution in the halos of these galaxies. That's one of the many research areas that we're working on.
Where does MOND fit into that? Do you have much time for MOND, or is that still too embryonic to...
No, MOND is brilliant. I mean, it's always very good to have an alternate theory. So the modified Newtonian gravity is a challenge for us, because they essentially say, well, we don't need dark matter. We modify Newtonian's law in space, and whoop, we can explain nearly everything. So what we try to establish is MOND valid everywhere. Can we falsify MOND, which we have done actually numerous times, but then the MOND researchers have said, oh, wait a moment, we can also work on our theory to improve it. So, you falsify one particular aspect, and then the theory also evolves and changes. So it's really important to compare the MOND explanations, for example, rotation curves of galaxies, with our puzzle that rotation curves don't fall outside, the stellar envelope, but they keep rotating at the same speed they rotate in the inner part. While the stars get dimmer and dimmer, the hydrogen envelope also decreases, but they keep rotating very fast. So there must be a lot of mass out there.
That's Professor Barbel Korobalski from the CSIRO's Australia Telescope National Facility and the University of Western Sydney. And this is SpaceTime. Still to come, a new location in the search for life on the red planet Mars, and the International Space Station forced to fire up its thrusters and take evasive action to avoid oncoming space junk. All that and more still to come on SpaceTime. NASA's Mars Perseverance rovers just arrived at a new location in the red planet's Jezero Crater, one which scientists think would be a good spot in the search for evidence of ancient microbial life. The car-sized six-wheeled rover has been exploring the top of a fan-shaped pile of rubble from an ancient river delta made up of sediments washed into a lake in the crater from further upstream. It's now reached rock deposits along the margin areas around the lake. Perseverance geologist Bronja Horgan from Purdue University says any life that once existed on the red planet may have left behind chemical clues that can still be found in these deposits as part of the rover's Martian campaign. Horgan says this new region could be a lot like a bathtub ring that extends around up to a third of the crater's inner margin. Orbital data suggests that it's filled with deposits of carbonate minerals similar to a shoreline or beach areas on Earth. Carbonates offer the potential to hold and preserve evidence of life that may have existed in the shallow water believed to have once been lapping along the lake's shoreline. The rover arrived at the margin region this week and has just started collecting samples. Perseverance landed in Jezero Crater, just north of the Martian equator, back in February 2021, and the margin area was always one of the main targets for exploration during the mission. The rover will explore the margin region until May next year. Mission managers also plan to examine a river channel which cuts through the rim of Jezero Crater and which was the source of the delta deposits. But as well as its primary mission, to search for signs of any past microbial life that may once have existed on the red planet, the rover is also collecting samples for eventual transport back to Earth as part of a joint NASA-ESA sample return mission slated for around 2030. Perseverance will also attempt to find igneous rocks that have been altered to form carbonates, thereby providing an opportunity to address additional astrobiological and environmental aspects of Mars's geological record. See, carbonate minerals commonly form in certain bodies of water on Earth when the water chemistry favours their precipitation, and this process can be mediated, or for that matter the precipitation of minerals caused, by the action of living microorganisms that inhabit the water. Horgan says that normally we see carbonates forming on Earth in very shallow water. And they're great for trapping signs of biological microbial activity because these shallow zones are being constantly fed both by light and nutrients coming in from beyond. Organ and colleagues will closely examine the textures of the carbonates they find in order to determine the potential they hold for signs of life. This is SpaceTime. Still to come, the International Space Station fires up its thrusters to avoid oncoming space junk. And later in the science report, scientists have for the first time sequenced RNA from an extinct animal species, the thylacine or Tasmanian tiger. All that and more still to come on SpaceTime. The crew aboard the International Space Station have been forced to take evasive action and manoeuvre the orbiting outpost away from out-of-control space junk that's hurtling towards them. Thrusters aboard the space station's Zvezda service module were ignited for 21.5 seconds in order to move the space station away from the predicted track of an orbital debris fragment. The thrusters lower the space station's orbit by 0.5 kilometre. The International Space Station has been forced to undertake course corrections more than 30 times since 1999 due to space junk. And that need is increasing exponentially as more and more satellites and space junk accumulate in orbit. NASA mission managers maintain a strict 4x50 by 50 kilometre pizza box shaped exclusion zone around the space station, with the US Space Force closely tracking any debris down to 5 centimetres which could encroach or penetrate that exclusion zone. Meanwhile, a Russian Soyuz capsule has successfully docked with the International Space Station just 3 hours after launching from the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan.
Vehicle on internal power. Copy.
There goes the first umbilical retraction. The second umbilical will retract in just a few seconds to initiate engine start sequence. T-minus 20 seconds. We have engine sequence start. We have engine ignition.
Second tower separation.
3, 2, 1.
Pumps at flight speed.
And liftoff. O'Hara, Kononenko, and Chu begin a short-duration journey for a long-duration mission on the International Space Station. All vehicle parameters are normal. 23 seconds into the flight. Good roll, pitch, and yaw program. Engine performance on the first stage nominal.
L plus 30 seconds. Flight is nominal.
40 seconds into the flight.
Well,
Structural parameters are normal. Engine parameters reported from the blockhouse in Baikonur, all to be within limits and normal. 1 minute 5 seconds into the flight.
Roll pitch, yaw nominal.
All the vehicle parameters are normal. Good reports coming in from the blockhouse in Baikonur. The vehicle arcing out to the northeast from the Baikonur Cosmodrome.
Параметры системы управления ракеты-носителя в норме. Двигатели первой и второй ступени работают нормально.
Good engine performance being reported.
184608. C off nominal pressure in case of 1500. Copy.
Тангаж, рысканье вращения в норме.
Coming up on first stage shutdown, and we have first stage separation.
Jettison confirmed.
Launch tower jettison reported. Everything in good shape.
First stage separation
2 minutes,
confirmed.
12 seconds into the flight.
KSO is back to nominal 980. Copy.
The vehicle now operating on its second stage engines. All parameters are normal. Good structural performance by the vehicle. Launch shroud jettison now reported.
Second stage separation confirmed. Copy.
Second stage separation confirmed. And the program has been activated, and the solar arrays and navigational antennas are now confirmed to have been deployed. Perfect ride to orbit for Laurel O'Hara, Ale Kononenko, and Nikolai Chub. The Soyuz and the International Space Station now flying over southern Morocco.
Expect the final approach mode transition. Range is 230, 025 is range rate. We see the course mode final approach. Yes, we see the fly round. MRM-1 is in the OSK center. Range is 225 and 0.35 is range rate. Antares, could you please expand the video so it covers the entire screen? Okay, copy. Expanding the video. Range is 140, is the final approach 0. Range is 70, 0.3 is range rate. We have the crosshairs aligned, so it's in the center. Range is 35, 0.14 range rate. 5332, we
contact confirmed, docking confirmed at 1:53 p.m. Central Time, 2:53 p.m. Eastern Time, as the station and Soyuz flew 260 miles over Ukraine, south of Kyiv. A flawless launch to docking scenario for Laurel O'Hara, Oleg Kononenko, and Nikolai Chub. O'Hara and Chub arriving at the station for the first time. Kononenko, an old hat at this. This is his 5th flight into space. It was dead perfect from launch to docking. This is Mission Control Houston. Once again, we're in the final phase of the leak checks and pressure checks on the Soyuz side of the docking interface at the Rassvet module of the International Space Station.
The Soyuz MS-24 delivered 3 new crew members to boost the 7 already on station. They'll eventually replace 3 of the current Expedition 69 crew who have now been on station for over a year and whose departure will mark the start of Expedition 70. The MS-24 crew was supposed to fly to the space station 6 months ago aboard the Soyuz MS-23 spacecraft, but their original ride was needed as a replacement for the other crew whose stay on the station was extended from 6 months to a year after their original Soyuz MS-22 spacecraft suddenly developed a coolant leak while docked to the orbiting outpost. Engineers with the Russian Federal Space Agency Roscosmos eventually determined that a micrometeoroid impact was the likely cause of the leak. But then just 2 months later, amazingly, the Russian Progress MS-21 cargo ship, which was also docked to the space station, also suddenly sprung a leak in its cooling system. And yes, both systems are similar. These incidents follow on from several air leaks that have sprung up both aboard Russian spacecraft docked to the space station and on modules in the Russian segment of the space station. Then there was the abort during ascent of the Soyuz MS-10 mission back in 2018, 2 minutes into the flight, when a strap-on booster crashed into the core stage of the Soyuz launch vehicle. Yet another incident involved the sudden unprogrammed ignition of a thruster aboard the new Russian Nauka science module after it was attached to the space station. That sudden thruster ignition sent the orbiting outpost tumbling out of control for 45 minutes, and it couldn't be turned off. Mission managers instead igniting other thrusters to try and balance the load until Nauka's thrusters finally ran out of fuel. The ongoing problems with Russian equipment appear to be rooted in poor quality control on the ground. But the problem is, the secretive Russian Space Agency refuses to go into detail about what their investigations uncover. And that's not filling other spacefaring nations with a great degree of confidence. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. Scientists have for the first time ever sequenced RNA from an extinct animal species. A report in the journal Genome Research described how scientists used muscle and skin samples from a 132-year-old Tasmanian tiger or thylacine museum specimen to isolate millions of RNA sequences. RNA genetic material provides information about the animal's genes and the proteins that were made in its cells and tissues. Obtaining RNA from historical samples is challenging because, unlike DNA, which is highly stable, RNA breaks down rapidly once living cells die. Scientists hope the RNA locked up in the world's museum collections could one day provide new insights into long-dead species. The Tasmanian tiger, or thylacine, lived on the island of Tasmania in southeast Australia. Farmers wrongly blamed the carnivorous marsupial for livestock losses that were actually being carried out by wild dogs. A bounty was eventually placed on the Tasmanian tiger by politicians. That led to the species being quickly wiped out, with the last remaining animal dying alone in the Hobart Zoo in 1936. Scientists have found that a daily low-dose aspirin could help reduce the risk of type 2 diabetes in older adults. The authors recruited 16,209 participants over the age of 65 and in good health and gave half of the group a daily aspirin dose and the other half a placebo. Following up just under 5 years later, the researchers say the group taking the aspirin had a 50% lower rate of type 2 diabetes than the placebo group. But the authors point out that the aspirin does come with its own set of risks. So much more research needs to be undertaken before making any changes to health advice for older adults. The findings of the study have now been presented at the annual meeting of the European Association for the Study of Diabetes. Iran has suddenly banned a third of United Nations weapons inspectors from accessing the Islamic Republic's suspected nuclear weapon sites. The International Atomic Energy Agency has slammed the unprecedented move as profoundly regrettable and warns that it harms the agency's capacity to monitor the Islamic Republic's nuclear program. Rafael Grossi, Director General of the International Atomic Energy Agency, says Iran's lack of cooperation will damage the organization's ability to provide credible assurances that nuclear material and activities in Iran are for peaceful purposes only. Grossi describes it all as yet another step in the wrong direction and says it constitutes another unnecessary blow to an already strained relationship between the International Atomic Energy Agency and Iran in the implementation of the Non-Nuclear Weapons Proliferation Treaty Safeguards Agreement signed in Vienna in 2015. Last week, the UN nuclear watchdog said Iran had made no progress on several outstanding nuclear issues, including the installation of more cameras to help monitor Iran's uranium enrichment program. The International Atomic Energy Agency says Iran's total stockpile of enriched uranium is still some 18 times above the limit set in 2015 under the Vienna Accords. As of August the 19th, Iran's total enriched uranium stockpile was estimated to stand at 3,796 kilograms. The agreed-to limit set in 2015 was 202.8 kilograms. Britain, the United States, France and Germany say the Islamic Republic must clarify questions about its nuclear program, including concerns over the mounting of cameras and the presence of uranium enriched to near nuclear weapons grade. Meanwhile, Israeli intelligence agents say Iran now has enough weapons-grade uranium to produce 4 atomic bombs, and it shows no signs of backing down its clandestine program. Hypnosis is a state of allegedly altered attention and awareness of the mind, but it's long been a subject of debate and intrigue. You see, the phenomenon is often dramatized in popular culture as a form of mind control, where the hypnotist dangles a swinging pocket watch before a subject's eyes and slowly says, "You're getting sleepy, sleepy." And then the subject mindlessly follows the hypnotic suggestion that's been implanted in him, such as clucking like a chicken whenever he hears the word bazinga. Hypnosis has a contentious standing in the scientific community, and it still needs some rigorous scientific investigation. Tim Mendham from Australian Skeptics says the jury's still out on whether it's a valid psychological tool backed by empirical evidence or whether it simply belongs to the realm of pseudoscience.
Hypnosis is obviously been around for a while. If you go back to mesmerising people back in the 1800s, the power of suggestion to make people do things, as you say, feel sleepy and being sort of prone to believing instructions. There are some people who are more prone than others, more amenable to instructions. Whether they're really under, as in when they go to sleep, etc., is a moot point. It has been used in psychology with mixed results and mixed views on it, and it's sort of used for treatment of pain and anxiety and depression, sleep disorders and PTSD and that sort of stuff, which is sort of very much all psychological issues rather than necessarily...
Are you really making people go to sleep when you click your fingers? And
I don't know. I honestly don't know.
And you count backwards from 3?
We've had articles about it, and we've sort of looked into we've looked into it. Other people looked into it, obviously, more than us. And the suggestion is yes, no, maybe. The depth of the sleep is questionable. The fact, what can you make them do? There's a lot of trickery about what people do on stage. Stage hypnotists, there's a lot of people helping out. Stooges or something in the audience who might do strange things.
You'll cluck like a chicken.
Yeah, I don't know if it ever goes to that extreme, if it's real, but they say there's some benefit from it, but there's also some major dangers. Yeah, you're putting people into regression or calling up repressed memories via hypnosis, assuming people are prone to believe hypnosis and it has some effect. The very nature and concept of repressed memories is a pseudoscience.
Yeah, a lot of people went to jail for that sort of thing. And
it's basically psychological humbuggery.
Happened.
For a while, it was very popular. It was the thing to sort of check out people's repressed memories. It's very based on Freudian psychiatry, and what the issue is that it's because people with traumatic experiences unfortunately can't forget. That's the problem. It's not repressed. It's actually right up there, up front, affecting them. And so the whole concept of this terrible thing happened and I blocked it from my memory is a bit of a myth. But it had a major impact in the 80s and 90s and things, and people who argued against it got death threats from the people who were making a living out of promoting repressed memory. And that's one of the areas that hypnosis has supposed to be used, and it's obviously very, very dangerous. So it's not just the fun thing of hypnotizing someone and acting like a chicken. It has implications. Even if hypnosis doesn't work, the fact that it's using it on people who might be sympathetic to it can have major problems legally, financially, ethically, scientifically, morally. It can do terrible things to people because of the belief in it. And people believe a lot of things that aren't true, but that can be a very powerful effect on people. So you've got to be very careful about some of these things, even though it might seem inane.
That's Tim Mendham from Australian Skeptics.
Bazinga!
That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.